everyone, in this video we're going to talk about momentum. Hopefully, by the end of this video, you should be able to tell the difference between three types of collisions: elastic, inelastic, and perfectly inelastic. So let's start with the basics. By the law of conservation of momentum, we know that in a closed system, the total momentum of two objects before and after a collision is the same. So, using variables, initial momentum is equal to final momentum. However, the kinetic energy before and after the collision may not be the same. So, initial kinetic energy is not necessarily equal to final kinetic energy. So, let's look at our first collision. So, in collision A, there are two carts that are moving towards each other with constant velocities of 6 meters per second and 3 meters per second. Cart number 1 is 8 kilograms, while cart number 2 is 10 kilograms. After colliding, they bounce apart with new velocities of 4 meters per second and 5 meters per second. So, qualitatively, we can predict that this collision will be elastic because I use the words bounce apart when describing the collision. Bounce apart indicates that not much of the energy, or none of the energy, was lost in the collision or absorbed by the impact. So let's see if we can simulate this collision. So we can look at two golf balls and see what happens when they go towards each other with constant velocities and they collide. So that was one. So in those three collisions, of course they weren't perfect, but the golf balls bounced apart, and it seems like not much of the energy was lost. Let's see if we can prove our prediction using numbers. So first let's check to see if the momentum is conserved. We can use initial momentum equals final momentum and see if that equation is true in this scenario. So by plugging in the numbers, we realize that the initial momentum is 18 and so is the final momentum. And that means that momentum was conserved as expected. Now let's see if the kinetic energy is conserved. That indicates whether the collision is going to be elastic, inelastic, or perfectly inelastic. So in this case, it seems that kinetic energy is conserved. By adding together the two carts' kinetic energy before and after the collision and seeing if they're equal, we see that the initial kinetic energy is 189 and so is the final kinetic energy. So clearly, kinetic energy is conserved, and that means that this collision is confirmed to be elastic. So now let's try to look at a second collision, collision B, and see whether this collision is elastic, inelastic, or perfectly inelastic. So, collision B is the exact same collision as collision A with the same initial velocities and the same masses, except after colliding, the two carts stick together and move to the right with a new velocity of 1 meter per second. So, since these carts did not bounce apart with the same kinetic energy as they did before, and it seems like a lot of the kinetic energy was lost in the impact, I predict qualitatively that this collision is inelastic. So this is because, once again, whenever a collision is inelastic, that means some kinetic energy was lost, and it definitely doesn't seem like these objects bounced apart with the same kinetic energy as they started with. I also will further classify this as a perfectly inelastic collision because of the key words stuck together. Whenever two objects collide and stick together in a closed system, that means that the maximum possible amount of kinetic energy was lost, and we can classify that collision as perfectly inelastic. Now, like before, let's prove our qualitative prediction using a quantitative method. So, first we can look at the initial momentum and final momentum. So, like before, as expected, the momentums are the same, because the initial momentum is 18 and so is the final momentum. However, we classify these collisions based on the kinetic energies. So if we do some number crunching with the kinetic energies and use the same formula as we did before, it seems like the kinetic energy is lost because the initial kinetic energy is 189 joules, while the final kinetic energy is only 9 joules. So, like we predicted, this collision is clearly inelastic. A significant amount of the kinetic energy was lost. And it's also perfectly inelastic, like before we could tell, because the objects stuck together. Let's see if we can simulate this using two cars with tape on them. Here's what it'll look like. The two cars are moving together with similar velocities, and they hit each other, and they continue moving towards the right at a slow speed. Since they did not bounce apart, but they stuck together, we can predict that the collision was clearly inelastic and perfectly inelastic because they stuck together. Thanks for watching.